Hello everyone. So today we are going to discuss one of the application of natural language processing, that is IR, information retrieval. So this topic actually comes under the natural language processing. Here is the contents of the NLP that is given in our syllabus. So what is the objective of today's lecture? So to learn and understand the NLP concept for information retrieval. Course outcome is that apply the concept of natural language processing to problems leading to understanding of cognitive computing. In today's presentation, we are going to cover overview of the current IR system, the problems with NLP in IR, major applications of NLP in IR. Motivation. So most successful general purpose retrieval methods are statistical methods. So sophisticated linguistic processing often degrade performance. So what is the IR? Information retrieval system is one that searches the collection of natural language documents with the goal of retrieving exactly the set of documents that pertain to a user's question, have their origins in library systems, and do not attempt to deduce or generate the answers. So what is the problem of IR? So goal is that to find the documents which are relevant to an information need from a large document set. For example, the information that is needed, the query that is executed, and yes, IR system is there, and the information is get retrieved from the information retrieval system while executing the query. So in general, we can say that there is a document collection, and where the many documents which are available, the user they want the some particular information, accordingly will execute the query, and with the help of the AI system, that document will be retrieved from the collected documents, and that will be the answer to the answer list. So it is very simple structure to get the documents, relevant documents from the document collection. The basics of the IR system is described here. So you can see at the left side there is a query. So representation function that can be used to represent that particular query. Then in the query the matching function is there, and that matching function search the index from the index table, and yes, that will be represented with respective or with a relevant document, and that will be retrieved from the documents. The relevant documents will be retrieved from the documents, and the matching function will check it and will give the results. So four steps basically: indexing the collection of documents in IR system, then transforming the query in the same way as the document content is represented, comparing the description of each document with that of the query, and finally listing the results in order of relevancy. In retrieval system, that consists of mainly two processes. The first one is that indexing, and second one is that matching. The first we'll discuss the indexing. So indexing is the process of selecting terms to represent a text. So it involves tokenization of a string, removing frequent words, and stemming. All these three phases we already discussed in natural language processing. There are different phases of the NLP that we have discussed. So in that we already discussed these three steps which are actually involved in the indexing phase. Two common indexing techniques, the Boolean model and vector space model. This is what the indexing we can see. That there are different terms like drink, hotel, Pune, soup, and tree. So this is what the terms uh, which are from the document, which are collected from the documents. And here we have to see the term drink is how many times is appeared in that document. Then the term hotel is how many times appeared in that document. So from this diagram, yes, we can see the drink, that word appeared 3 times in document, hotel 1 time, Pune 2 times, soup 2 times, trip 2 times. Then how we can extend this? Because if there are the collection of documents, so we can say that the drink word may be present more than one documents. So that will be again considered here at the right side. So drink word is present in 3 times in a documents, and the document indexing that is given 1, 2 and 3. Hotel, that is appeared, this term appeared in only one document, that is document number 3. Then Pune, that appeared in 2 documents, document number 2 and 3. Soup, that appeared 2 times, that is document number 1 and document 2. And trip appeared 2 times, that is document number 1 and 2. The information retrieval model that consists of the first of all representation of the documents, D, representation of the queries, Q. Here R is taken. F, a modeling framework for D, Q. So here actually Q is considered by mistake, R is there. So R, that is what the representation of the queries, and Q for the query. So R of, we can say that relation or the representation of Q, Di, a ranking or similarity function which orders the documents with respect to a query. So in this, tokens are treated in the form of ones and the zeros. Boolean model. So queries are represented as a Boolean combination of the terms. So set of documents that satisfied the Boolean expression are retried in response to the query. So drawback is that user is given no indication as to whether some documents in the retrieved set are likely to be better than others in the set. So this is what the basic drawback with this Boolean model, and that's why the advanced model is there. It's called as the vector space model. So in this model, the documents and the queries which are represented by vectors in t-dimensional space. So t is the number of distinct terms used in the documents, each axis that corresponds to one term, and rank list of the documents that ordered by the similarity to the query, where similarity between query and the document is computed using metric on the respective vectors. So how to match it, that particular the term matching with that particular documents. So here matching formula is there, and with the help of that matching formula we can say that the process with the help of the terms get matched with that particular documents. From that we can easily find out the relevancy of that term with the documents. So matching is the process of computing a measure of similarity between two text representations. So relevance of a document is computed based on the following parameters. TF is the term frequency, is simply the number of times a given term appear in that document. So the formula is given. So term frequency, the formula is given count of ith term in J document upon total terms in J document. IDF is the inverse document frequency, which is a measure of the general importance of the term. So IDF is equal to total number of documents upon number of documents containing ith term. So it can be represented like that. The score is equal to TF into IDF. Evaluation of the IR system. There are two common effectiveness measures that includes precision and recall. So what is actually the precision? It is a proportion of retrieved documents that are relevant. It is near to accuracy. So precision is equal to number of retrieved relevant documents to the total number of relevant documents. So how many documents which are relevant documents which are retrieved with respect to the total number of relevant documents. For example, 10 documents which are relevant, but only the 6 which are retrieved which are relevant to the document. That is what the precision. Recall is that proportion of the relevant documents that are retrieved, that is equal to number of retrieved relevant documents to the total number of retrieved documents. So here whatever that retrieved relevant documents is considered, with respect to the total number of the retrieved documents. For example, 10 documents which are retrieved, but out of that only the 5 documents which are relevant. So recall will be a 5 upon 10, we can say that. So ideally both the precision and recall should be 1. In practice these are inversely related. So there is some case study. Yes, you can go through this. You can easily search the query. I need to know the gas mileage for my Audi 8 2004 model. So Yahoo search engine is used here. So you can see the results. So purely text match search is there. So no deduction or answer retrieval is there. So you can find out. So here the results that we have. So you can see the whatever that uh, query is given. I need to know the gas mileage for my Audi A8 2004 model. So which may be present or available in some particular documents as it is. So the terms get matched with that documents and retried here. Yes, you can see here no proper answers to this question, and neither is the result concerned about the sites discussing about the actual question. So I need to know the gas mileage for my Audi A 2004 model. If you search in the Google, yes, actual answer is there by deduction. Yes, you can see. So whatever that query is given will be reduced, and yes, the actual result that is actually want to the customer. So want to the user, we can say that. So Google actually gives it. So there are Yahoo search case studies there. It is purely text based search. Result generates instance of same text containing documents. Then YQ search is there. So yeah, these are the actually old the contents which are taken from the slides, and that's why actually the Yahoo search and YQ search is nowadays actually it is get advanced. Google search, it is efficient use of NLP for deduction of answer from given question, a step towards questioning answering. So conclusion is that research efforts to address the appropriate task are underway. So document summarization and generating answers, which are the examples for that. And yes, the most of the research is going on this document summarization and generating answers. So achieving extremely efficient NLP techniques is an idealization. So references which are given here, and from that references actually the slide presentation is prepared. Thank you.